Good day, everyone. This is Shekhar Malani, and good day, everyone. This is Shekhar Malani, and I firstly am thankful to the opportunity given today by Amrita University to share my thoughts on the upcoming EV ecosystem. And special thanks to Dr. Rajesh Kannan for having me here today, and to Naveen for the coordination he has been doing with me for the last couple of weeks. Firstly, I apologize for not being able to be there in person. I am traveling right now and could not make it personally, but I look forward to future opportunities and being there in person as well. Today's topic that I'm going to talk about is regarding battery life cycle. And battery is very centric to the upcoming ecosystem of the electrical infrastructure of the electric vehicles. And we will talk about what opportunities and challenges are there in these areas. So, as most of you are aware, the EV is made up of very few components compared to a IC engine vehicle. And amongst that components, we have the high voltage battery pack, which is the costliest component on the vehicle, and also the main power pack of or the fuel tank of the vehicle. Apart from that, we have the power electronic control devices, which are then regulating the power that is going from the high voltage battery pack to the other devices. Beyond that, we have the traction motor, which is finally doing the conversion from the electrical energy to the mechanical energy and moving the vehicle forward. And finally, we can say the control aspect, all the controllers, be it the motor controller, the battery management system, the vehicle controller that is working on 12 volt or 24 volt and catering to the other aspects. So out of these four components, the high voltage battery pack plays a major role. And in a sense, battery pack is simple. It is made up of cells. The cell has an anode, a cathode, and in between we have a electrolyte. When we take multiple such cells put together, we can create a small battery, and we take multiple of these batteries next to each other. We create a module of batteries. And this module then can be sufficient to run our vehicle, or we may need more than just one module. And that is where multiple modules come together to deliver what is called as the battery pack of the vehicle. So cells to modules to pack, this is how the industry is working right now. But as you are aware, we have been looking for high energy density materials to be used for the cells. And that is where we have landed upon the lithium ion based chemistries. So today, we are packaging these anodes and cathodes in multiple form factors. We have cells which are cylindrical, just like a Coca-Cola can. We have cells which are prismatic, like a fruity. And we have the cells which are like a pouch, like paper boat format. And we have these three different ways of packaging the cells. Now, there are advantages and disadvantages of each of them, and we can realize that all of them are being used in the industry. All our cell phones are working with the pouch cell. Most of the EVs are either with the cylindrical cell or the prismatic cells. And all these three shapes are finding a market today. Within this, the cylindrical has some standardization. So there is this 18650 cell 21700, where 21 is the diameter, 21 mm, and 70 mm is the height of the cell. So these are standard nomenclatures that have come in the ecosystem. Such standardization, however, is not there on the prismatic and on the pouch cells. Now, when it comes to the lithium and the anode and the cathode, there is certain dependency. So first of all, lithium is not available in every geography. There are countries like Australia, like countries in South America, where lithium is dominantly available. And further, this lithium, which is available on the earth, has to be refined. And most of these refineries are in the China. So there is a dependency of the supply chain to China. So whatever may be there in Australia, maybe there in South America, first has to go to China and get refined, and then it goes into the batteries worldwide. Today, most of the batteries getting produced or cells getting produced are from China, are in China, and the major consumption is also in the Chinese market. But that is changing. Other geographies are also now having a lot of demand of lithium ion batteries. Now, if we see 74% of the lithium that is coming out is getting used in batteries. So that's a significant number. 74% of all lithium coming out is getting into the uh, batteries. And within that lithium batteries, we have different components, as we have talked about, the anode and the cathode. Within this, the cathode is very important because it has some costly materials going into it. So 50% of the cost of the battery or of the cell is coming to from the cathode, and cathode has nickel and cobalt, which are the expensive material, and that needs to be understood as well, that especially cobalt increases the cost of the battery. So from the supply chain, cobalt really maximum coming from this Democratic Republic of Congo, going on to refineries in China and then getting used in the cell manufacturing in China. So 80% of all cell manufacturing is happening in China. Then we have the anode, which is typically made of graphite. So there are companies locally available in China who are doing that. Then other elements like the separator, where the core elements are going in the separator, and electrolyte, the specialized formulations which are ensuring that the lithium ions have a free travel path, and there is no short circuiting because of electron passage. So today the cost of a lithium battery is significant. And as we keep consuming more lithium, we have to look at considerations of ensuring that we can recycle lithium in the future. We can recycle cobalt in the future and not be dependent on new every time. So there is a lot of effort the industry is putting in coming up with these plans of how we will get lithium back from the batteries which are already made and start putting them into the new batteries as well. So per regulation, the batteries that are being used out there right now are classified into different categories. We have one category which is the automotive battery. This is our typical lead acid battery, which is being used in the automotive for years and years. Then we have the batteries for light means of transport like e-bikes, e-scooters. So these are very low power batteries, maybe around 250 watt and less, and getting used in e-cycles and small e-scooters. Then we have the industrial batteries, either getting used for energy storage in solar and industrial purposes, or mobilizing the EV. So that is there. And finally, the hand carried like rechargeable batteries, or what we call as the portable batteries. So these are the main classifications. And we are talking about recycling and getting this material back from all of these areas, not just one of them. So obviously there is an increasing demand for batteries. The battery is going to be used for storage of renewable energy from solar. It is also going to be used to power our mobility. So low carbon mobility, or what we call as a zero emitting vehicle. And then the digital economy, or basically cell phones, are also big of the this uh, batteries. And then if we just look at the demand, as the number of electric vehicles, battery electric vehicles are increasing, number of plug-in hybrids are increasing. Just in the European Union, the share of new registrations is already coming to 10%. So 10% cars are electric. So that's becoming a significant portion. And in India, we are going to see a similar roadmap come through. We are right now reaching 10% in the two-wheeler scooter space. And then in the other spaces also, the percentage is going to increase. So that means we will need a lot of more lithium. We will need a lot of more cobalt. And by 2030, we need a lot. And by 2050 also, we need a lot. Now, these numbers are representative of the EU market, but you can imagine a similar situation happening in India. So what we have to look at is the understanding of what are the critical raw materials for the future. And if you see looking at what industry wants and what is rare, what is tough to obtain, there are these different critical raw materials which have been listed. And you can see here a lot of things going into the battery, like cobalt, like lithium, some additives which are sometimes added, like vanadium, things that are going into magnets, like heavy rare earth elements like neodymium and samarium. A lot of things for related to electric vehicles is here. And for us, from the battery, the cobalt and the lithium are the key elements here, which are going to be very, very important for the future. And that is where all the way from the entire life, we need to map how this is getting used. So from the extraction and mining to the production of the batteries, now the battery is made, it goes into its primary use, which is the vehicle. And from that, once from the vehicle it comes out, it has to go into some sort of a second life. So what we are saying now, it has lost certain health. It is no longer good for use in automotive segment. And this may happen in a period of 8 to 10 years. of usage. We don't know how much exact time the battery will last. It is dependent on the usage. So 8 to 10 years, get the battery back, give it for a second life. This second life may be solar energy storage, street lights, all these things, household inverters. And then once that second life is over, that is when we talk about doing recycling. And till this battery goes to recycling, the ownership is that of the battery producer or the repurposer. So first the battery was produced and given to a OEM, like it can be say Tata Motors, and Tata Motors has put it in a vehicle. So the ownership of the recycling is with Tata Motors. Let's say Tata Motors has now taken out the battery after 10 years, and they have given it to a company called as Nunam, who are doing second life batteries, and they will use it in a solar street lights. So Nunam is going to take a battery pack, break it into smaller batteries, and then use it for multiple street lights in the second life. And then the ownership is with Nunam, and the Nunam has to bring it back and take it to a recycling at the end of the second life. And from the recycling, the recycled material like lithium, cobalt is going to go back to production and get mixed with the fresh mined components and be used. So that is like a circular economy that we talk about. Now, that means there has to be proper ways of collection of these batteries. There has to be way to collect the battery, and it needs to be evaluated whether it is to go into waste, or whether it can be repurposed, or whether it has to go to recycling. Right. So there is a lot of focus on collecting the batteries back from the market, and very stringent collection targets are imposed in Europe. In India, we have similar discussions going on, and all waste from automotive, industrial, and electric vehicles has to be collected. So this is very important. Now, overall, we have multiple places in this circular economy where we can play a role. So there is an original battery coming in the vehicle, which has come from the battery vehicle manufacturer. The vehicle manufacturer has taken the battery from a pack manufacturer. The pack manufacturer has assembled the battery from multiple modules, and the modules are made up of multiple cells. Now, there may be a case where within even 3 years, the battery needs a replacement. So I don't want to go and buy a new battery. I can use a remanufactured battery, which had some issue, one module not working, create it again and make a remanufactured battery pack, and that can be used with the vehicle. Now, end of life of the vehicle, whatever, 10 years, 12 years, 15 years, the battery is going to come out. We will remove the battery pack, and from the pack removal, we are going to do a testing. This test is very important because this will decide whether it goes for a secondary usage like home storage, or it goes for recycling. So very, very important testing, and there has to be someone who will do this testing, right? And then if it goes into second life, finally from second life, it will come back to recycling. So another few years, it will be back. Now in this recycling, the materials have to be taken out. So material extraction process has to be developed. How to take out the cobalt, how to take out the lithium, very, very important. And then these materials need to be taken back and given to the cell manufacturer. So this complete circular method has to be coming up, and there are multiple roles which are absent in the Indian market right now. So there is a lot of opportunity to take this up. So recycled content, as far as European market goes, in 2030, any new battery being made in Europe, any new cell being made needs to use 4% recycled lithium, 12% recycled cobalt, and 4% recycled nickel. That is in 2030, and then that percentage will keep on increasing to in 2035, it will further increase. Now, in order to do this usage, and this is compulsory. So then companies want recycled content, and then someone has to do this recycling. So recycling technology investment is required. Recycled content otherwise would not be cost competitive unless this mandate is given. So with this mandate, the recycling is getting a push. Now, along with this, each battery that is being made, at least battery which is having a capacity greater than 2 kilowatt, is also going to have a battery passport. That means it's a unique number with the battery. So a QR code with every battery is going to be there. It is going to include a lot of details about how this battery was manufactured, where are the cells coming from, which mine it is coming from, and also talking about where to take this battery pack for recycling. Who is the collector of this battery pack? So a sample battery passport information, you can see what all data is going to be captured, like battery type, battery module, and who is the owner of this battery right now. So battery was sold to the automotive OEM, as we were talking about Tata Motors. It is built into a car. The car is sold to the consumer. The consumer has come for a battery repair. So complete life cycle is being tracked for that battery. And very, very important, what we are also tracking is the battery health. Right, so very important elements are going to be captured in this battery passport. Also, end of life collection information. So every battery will already include the name of who is the company or person you need to take it for recycling at the end. Where do you need to give it? Right, so this is a battery passport example coming from the Global Battery Alliance. So companies have already started using battery passport in Europe, and this is a battery manufactured via Audi, and it is giving all the details of the battery. Then additionally, it is talking about the materials. Where is the material coming from? Where is the cobalt coming from? Where is the lithium coming from? And where is this? Where is the mine located? Which country? So you can see DRC, Democratic Republic of Congo, and the lithium is coming from Chile. So all this is captured in the material, and inspection of the mine is also to be done to ensure that the mine is not using any child labor, first of all, and it is not doing any manipulations, and it is following all the ESG requirements. So the social responsibility, environmental and social governance is there at the mine. Now, all depends on individual area. Where are you in the supply chain? Are you a miner? Are you a refiner? Are you a producer of cell components? Are you a producer of the cell itself? Are you then taking the cells and building it into the battery pack? So the passport, the battery passport becomes alive at the battery producer, but it has information collected from all the preceding layers. Then the battery passport along with the battery, physical battery, is given to the OEM to put in the vehicle. Then the OEM sells the vehicle to the end user, and that is also coming. Then the battery passport is getting handed over. Then the vehicle at some time is going to go to the collector or the remanufacturer. Again, battery passport will change hands, and then from the recycler finally going back to the refinery to be used in a new cell. Right? So it's amazingly well laid out. Every company, every area has their role to play. And again, we'll not go into all the details, but what is the data collected from the mine, from the refiner, from the component producers like companies making the anode and the cathode, and what is going to be obtained from the cell and module producer. And similarly, then what gets handed over from the passport till the complete end of life of the battery. Right. So in a way, we have to look at the opportunities, right? Uh, I know this is battery. You may have questions. Is this the right way? Is lithium the right thing? Would there be other things coming? Yes, but everything will come with a requirement of sustainability and the requirement of circularity of the economy. So whatever we are putting out has to come back and be recycled. And that is why we have a lot of opportunities. Battery collection, refurbishing of the battery, taking the battery, repairing it, putting it back into a vehicle that had an accident, for example. So give a refurbished pack, repurpose the pack, take it out of automotive use and put it to stationary use or solar use, right? Then integration. Every time we are opening the battery pack, there is opportunity for integration. There is opportunity for diagnostics and troubleshooting. So these are opportunities to look at with regards to this battery ecosystem. At the same time, there are challenges. There are challenges that India has as a country with regards to the raw material. The lithium now, there are some local mines, local availability. So mines are going to be set up. So there is a lot of opportunity, but challenge to bring it into the ecosystem. There is dependency on China, which is a challenge. Material traceability. These mines are located in countries where there is no strong governance. So are the mines going to provide all the right data? What is the accountability of the mines? Are they following the environmental and social governance elements? And then very big challenge is the recycling. How much of lithium, how much of cobalt we can take out? And then who's going to police this? Who's going to form the rules? That is also kind of a challenge which over time should evolve, right? So overall, just wanted to share about this battery life cycle and the fact that there are a lot of opportunities to play a role in this, and whether EV, not EV, batteries are not going anywhere. Batteries and electrical storage, energy storage is the future. And that is where I strongly hope that you consider the opportunities and also look at the challenges and come up with your ideas to cater to the challenges. So this is Shekhar Malani signing off from this session. Thank you very much.